Welcome to the Future City Studio, where we are investigating urban waste systems by asking how should we rethink, reconfigure, and redesign our urban waste systems in order to achieve a more resilient and sustainable future city.
Waste is unserviceable material remaining over from any process or manufacture, the byproduct of any industrial process, or material or manufactured articles so damaged as to be useless or unsaleable. Waste can be divided into three categories, mainly solid, construction, and biological waste.
Solid waste is any garbage or refuse resulting from industrial, commercial, mining, and agricultural purposes and from community activities. Examples of this include items such as clothing, paper, and plastic.
Construction waste is the major wastes that are produced by construction and demolition industries. Examples of this include materials from demolition, public waste, infrastructure, and industrial waste.
Biological waste is comprised of food and kitchen waste, market waste, yard and park waste, and residues from food and wood processing industries. Examples of this include garden waste, food waste, and animal waste.
Globally, urban waste is a big concern to the environment, communities, the economy, people's health, and many more factors. Of the 2 billion tons of solid waste produced globally, only 20% is recycled and 58% ends up on landfills or dumping sites. The built environment accounts for 39% of the world's gross annual emissions as a result of producing 5,360 metric tons of construction and demolition waste per annum. 1.3 billion tons of food produced is wasted annually, and it accounts for an estimated 4.4 gigatons of greenhouse gas emissions every year.
For this studio, however, we focus specifically on Hatfield, Pretoria, South Africa. Hatfield is situated within Pretoria, one of the fastest growing cities in South Africa and also one of its capital cities. Hatfield covers an area of 25 square kilometers and is home to approximately 15,000 people.
Within South Africa, our current situation is similar to that of the global scale, with high concerns regarding waste management practices and disposal. South Africa produces 30.5 million tons of solid waste per year, with only 13% of this being recycled and the remainder going to landfill. 8.1% of general waste is made up of construction and demolition waste, with 5.36 million tons of waste being generated per annum, and most of this goes to landfill. 31 tons of food waste is produced in South Africa per annum, with 10 million tons of this being disposed of in landfills.
So why is all this waste such a problem? The problem with all the waste is that it takes up land space, which could be used to accommodate the need for space in cities created by rapid urban development on our continent. Furthermore, it creates unsafe living environments, which lead to health issues in communities, putting a strain on limited medical resources. There is also an economic impact because by mining raw materials and sending this to landfill once deemed to be waste is putting strain on our limited natural resources. Landfilling of waste also causes increased transportation to move the materials from one site to another, which places a burden on the transport infrastructure within our country. The greatest global concern is waste management's effect on the climate crisis and global warming.
So what is causing this to happen? When we look at the laws in place with regards to waste in South Africa, we see that in 1989 the first laws regarding landfills were introduced. These laws demarcated between general and hazardous waste and specified a few rules and regulations about the development and placement of landfills. This was the beginning of the age of landfill. The White Paper in the year 2000 and the Polokwane Declaration in 2001 were the catalyst for the beginning of the recycling era, which allowed for more regulations to follow regarding recycling. This continued until in 2008 the National Environmental Management Waste Act sparked a flood of regulation regarding the processing, handling and disposal of waste within the country. This included the Rhodesa Tire Industry Waste Management Plan. The development of these laws have shown us how the waste landscape has changed over the years from an age of only landfilling to the concept of recycling being introduced. This was followed by an influx of regulation, which was meant to be positive. However, this resulted in businesses not being able to participate due to the heavy financial burden of applying these laws. Going forward, we want to see if this can be changed.
To ensure that all strategies and interventions proposed by all three groups are implementable and grounded in legal frameworks and legislation, the proposals and design processes are all rooted in the prominent spatial design principles outlined within the Spatial Land Use and Management Act of 2013, or SPLUMA for short. These principles include spatial justice, whereby past spatial and other development imbalances are addressed; spatial sustainability, whereby development is within the fiscal, institutional, environmental, and administrative means of the Republic; efficiency, whereby development optimizes existing resources and infrastructure; spatial resilience, whereby flexible planning systems ensure sustainable livelihood in communities most likely to suffer the impacts of an economic or environmental shock; and finally, the principle of good administration, whereby all spheres of government ensure an integrated approach to land use and land development that is guided by spatial planning and land use management systems as embodied in this Act.
The current zoning in Hatfield includes the UP campus and residential, making up majority of the zoning, sports fields and parks, embassies, commercial and retail, and the boundary of the Hatfield CID, which will be touched on a bit later.
We started this project by mapping Hatfield's waste landscape for Ivan Cardenas, a master's student from the University of Twente in the Netherlands. His study aims to develop an urban digital twin prototype for improved solid waste management in Tshwane, and to uncover what the spatial distribution and characteristics of collection points and illegal dumping sites are.
Using the Hatfield Waste Mapping Survey on the EpiCollect app set by Ivan Cardenas, we are tasked with surveying all 25 square kilometers of Hatfield. We needed to identify and mark all the bins and instances of littering within the area and answer a few questions regarding these elements. Within 2 days, we were able to tag 2,220 reports of bins and littering instances across Hatfield. And from this, we discovered that Hatfield is a lot cleaner than we expected. From the 2,220 reports, 1,288 were bins, 921 were littering instances, and 11 were other, which were cases of waste that were not deemed as solid waste. Only 3.8% of the bins were broken, and 33.2% of the bins were movable. With regards to littering, 74.9% of the reports indicated minimal littering in the area. This helped from the basis upon which the groups could further investigate their specific waste categories.
We looked into where this waste goes and discovered that majority of this waste is going to landfill sites around Pretoria. There are 3 main landfill sites within the area, with the Heatherley Municipal Landfill in Mamelodi being the closest at 19.3 kilometers from Hatfield, Bonaccord Landfill being the second closest at 23.9 kilometers away, and the Mooiplaats Landfill being the furthest at 38.3 kilometers away.
South Africa's existing waste management system practices functions as follows. Waste is classified as general or hazardous, and all hazardous waste is taken to a separate landfill. General waste is classified into construction, solid, and biological waste. Construction waste is inspected, and if contaminated, it is taken to landfills, and if uncontaminated, it can be tested, graded, reused, and repurposed. Solid waste management is divided into the formal and informal sectors. Recyclable materials can be taken to buyback centers, recycling centers, or collectors, and the remainder goes to landfills. Biological waste is separated into contaminated and uncontaminated waste, the former going to landfill and the latter can be taken to compost and mulch facilities.
Waste has a big impact on the environment. Material making and site development in construction with functions of mining excavation, manufacturing, construction machinery, high volumes of water use, transportation, landfill contribution, and site excavation contribute to resource overuse. Food waste, illegal dumping, methane emission, and hazardous waste, which are considered biological waste, constitute to soil contamination. An inadequate collection system, disposal system, and illegal dumping and littering has led to health hazards, drainage blockages, landfill contribution, unsightliness and unpleasantness, and traffic congestion. This contributes to the waste of land problem that our country faces in urban areas. Furthermore, waste contributes to air pollution, water pollution, energy consumption, wildlife and marine life harm, and sound pollution. We also looked into the urban infrastructure systems within Hatfield, water and wastewater management, energy provision, transportation, and land use management are systems for which infrastructure needs to be provided within Hatfield. These systems are intertwined, with each providing infrastructure and resources for the other, therefore they all need to be considered within the city and how waste management intertwines with this.
These are some of the stakeholders we engaged with during the project. Firstly, Ilse Uckerman, who is a sustainability expert at the University of Pretoria. Then the Hatfield CID, who provides security and urban management services to the area with the aim of creating a world-class suburb. And finally, Johan van der Merwe, who is a senior lecturer at the Department of Civil Engineering at the University of Pretoria, as well as Julia Tucker, an honours student. The University of Pretoria's solid waste management system works in the following way. Students, staff and visitors place their garbage into bins, from where UP staff and contractors separate waste into recyclable and non-recyclable materials. From there, the recyclable materials are sorted and transported to recycling centres, and non-recyclables are taken to landfills.
UP's current bio-waste management is comprised of collecting green waste from all UP campuses. This includes Groenkloof, Prinshof, Onderstepoort, and main campus. Waste is transported to a composting facility on Elsie de Villiers, where it is turned into compost and fertilizer, which is then either sold or transported back to the campuses for use on the sports fields and landscaping. Green waste that is unusable is taken to the waste groups Bonnecourt or Mooiplaats landfills.
As mentioned previously, the Hatfield City Improvement District, or Hatfield CID for short, aims to see Hatfield become a world-class suburb by providing security and urban management services to the area. The CID has essentially absorbed the roles and responsibilities of the municipality through various bylaws and legal frameworks. The private non-profit organization now takes care of general landscaping and tree maintenance, cleaning and tidying of streets, enforcing the law through private security, and monitoring the Greater Hatfield area through private surveillance. In recent times, the CID has also started taking care of hard landscaping, such as broken sidewalks and bollards, as the municipality has increasingly neglected most of its roles.
Our stakeholder, Dr. Johan van der Merwe, an engineer working at the University of Pretoria's Engineering Department, shed some light on the topic of waste in the construction industry. He explained how the existing systems mines materials from the earth, produces products from these materials, and constructs buildings with these materials. The building is then completed, lives its lifespan, and is demolished. Each of these stages causes CO2 emissions, which are contributing to the global climate crisis. He introduced us to the possibility of introducing a circular building economy where materials are taken from end-of-life buildings and repurposed in new building projects, thereby minimizing the mining of natural resources required and in turn reducing CO2 production. This new process can be conducted by sourcing data from GIS mapping, detecting elements available from end-of-life buildings, disassembly of deconstruction of these buildings, distribution of these materials, and new design development processes.
We will now introduce the urban strategy principles behind each group's intervention in improving the 3 types of waste systems in Hatfield. Bio-waste will be focused on interconnection, energy production, and culture creation. Construction waste focuses on creating people infrastructure, craft community, and urban mining. And solid waste will look at spatial justice and repair, and the incentive of cleaner neighborhoods creating safer neighborhoods. Taking into consideration each waste group's strategies as a whole, we will create an interwoven, safer, and sustainable Hatfield and surrounding areas. We envision Hatfield 2.0, a future city driven by the people for the people. The core concept behind bio-waste strategy is turning bio-wasted opportunities into a bio-wise urban transformation by exploring the parameters and dynamics of bio-waste as a system in Hatfield.
The solid waste group's urban strategies are focused on defending the informal recycling sector and reimagining the fences and barriers to solid waste recycling in Hatfield.
The Construction Waste Group's urban strategy is rooted in the concepts of material innovation as a means of improving infrastructure and rethinking the construction waste management processes and centres in Hatfield.